Dakota Green Power announces that its new line of waste-to-energy systems use the sandwich gasifier, making their systems highly sustainable and uniquely reliable. Sandwich gasifiers are cleaner, more efficient, and more productive than previous systems. This means that instead of being a liability, wastes can now be turned into renewable energy resources that offset the use of fossil fuels and will make waste management more sustainable. Since the earliest days of civilization, waste has been an issue. Mankind's resource utilization trajectory, or rut, of take, make, use, and dispose is unsustainable and increasingly unstable. The world is consuming increasing amounts of fossil fuels, releasing more and more greenhouse gases, and has far too much waste piling up where local populations cannot handle them. Products from irreplaceable fossil fuels are often being used once and then thrown away. Improper disposal contributes to polluted landscapes, water contamination, ocean pollution, excessive greenhouse gases, diminished resource reserves, and decline of public and environmental health. The waste being produced by large population centers is becoming overwhelming. The downcycling economy has been with us since the beginning, and it has always been a problem. Since not all parts of the world have access to proper waste management, the practices of open dumping, open burning, and disposing of waste into rivers contaminates our land, air, and sea. Up until now, our waste management options have been limited to landfilling or incineration. This means we can bury it, or we can burn it, or we can benefit. For those that are unfamiliar with gasification, a little review may be helpful. Combustion is the familiar process of burning, but all you can get from it is heat. The best an incinerator can hope to do is burn wastes to make steam to generate electricity. However, relatively little of the energy present in the waste can be captured because of the high flow rates of the large quantities of air and exhaust gases that are involved. Combustion requires 3 to 4 times more air than gasification and produces toxic pollutants that have to be captured. However, this is costly because of the large volumes of exhaust gases that are being produced. In contrast, gasification uses just part of the chemical energy in the waste to create heat, and that heat is used to convert the rest of the material into syngas. Syngas is a combustible mixture containing hydrogen, methane, and other energy-rich gases. Syngas can be used as a fuel for internal combustion engines to generate electricity more efficiently than steam power. However, syngas can also be used to make liquid fuels such as methanol, gasoline, diesel, aviation fuel, or other high-value products. These products can be far more valuable than electricity. In certain markets, these options can greatly improve the bottom line for clients. When food wastes or other decomposable materials are gasified, this prevents the release of methane into the atmosphere. Since methane is a greenhouse gas that is 80 times more potent than carbon dioxide, gasification can have a rapid and potent effect on reducing climate change contributors. Also, because gasification has so little oxygen available, it can't make dioxins or furans, forms of toxic pollutants that are produced by incinerators. These and other pollutants are costly to remove from incinerator emissions. In contrast, because virtually all of the gases evolving from the gasifier are captured and processed to make clean syngas, pollutant emissions from a gasifier are near zero. These advantages of gasification have been recognized for decades and are why there have been so many attempts made to achieve economically sustainable waste-to-energy processes using gasification. However, conventional gasifier designs cannot process these materials profitably. This is largely due to the excessive amounts of tar, char, and clinkers that they produce. Having to remediate those issues result in higher capital and operating costs that diminish the economic sustainability of conventional gasifiers and have resulted in many, many failures. Dr. Nikhil Patel, the inventor of the sandwich gasifier, is an aerospace engineer. He gained a deep understanding of how to control heat and chemical reactions from his years of training in rocket science and his decades of research into the failures of previous gasifiers. During a television interview taped during an early test phase of this project, he was famously quoted as saying, "Converting wastes into energy is not rocket science. It is far harder than that." Dr. Patel is the only person on the planet qualified to make that statement, and his creation, the sandwich gasifier, required several technical insights and breakthroughs to succeed in gasifying waste sustainably. Like many advanced technologies, there is an elegant simplicity in the sandwich gasifier, but it took a tremendous amount of work to make it look easy. The sandwich gasifier applies technological advancements to ensure tar and char are minimized and that the clinkers which form are easily manageable. This approach not only makes the sandwich gasifier more efficient, it also avoids capital and operating costs, as well as parasitic drains of power production that have prevented conventional gasifiers from becoming economically sustainable. The design of the sandwich gasifier is what makes it unique. To maintain the temperatures required to produce syngas of the desired composition, the sandwich gasifier maintains oxidation zones above and below each reduction zone. This sandwich of oxidation and reduction zones maintain consistently high temperatures throughout the reaction chamber, ensuring that all combustible feed material is converted into syngas. In this footage, we see a waste feedstock consisting of paper, plastic, and food materials being introduced to the sandwich gasifier. The heat from the oxidation zone causes devolatilization of combustible gases from the material, and this heat is in turn used to release syngas from the material in the reduction zone. If this was combustion, there would be enough oxygen present for those gases to be burned as flames would be formed, but instead they are captured and their energy is saved for use later. The amount of hydrogen in the syngas can be maximized, or if the syngas is intended for use in producing liquid fuels, the energy content of the carbon molecules present can be maximized. The products of syngas from gasification include electricity and heat, but also include hydrogen, liquid fuels such as methanol, gasoline, diesel, jet fuel, or other valuable products. The technology required to turn syngas into liquid fuels is well established and has been in use since the 1930s. Therefore, converting waste into liquid fuels or electricity would have been practical long ago if only there had been a sustainable gasifier available. Many attempts were made, and although millions of dollars were spent by many companies, none could overcome the fact that conventional gasifiers encounter serious problems when processing waste feedstocks. In a side-by-side comparison processing identical feedstocks, a conventional gasifier rapidly formed clinkers that blocked its air injector ports. Even though attempts were made hourly to keep the injectors clear, syngas production steadily diminished and the system had to be shut down after just 6 hours. The photograph shows the injector port after the conventional gasifier was disassembled for inspection. It can be seen that clinkers formed around the injector and totally obstructed it. In contrast, Using the same feedstock, syngas production by the sandwich gasifier steadily increased during the first hour and then held stable for the next 5 days of continuous operation. Even after running several additional feedstocks, including some with very high ash contents, the sandwich gasifier's syngas production remained steady. When it was eventually disassembled for inspection, its interiors had remained free of clinkers. The uniformly high temperatures and complete control of gas flows throughout its reaction chamber make the sandwich gasifier's syngas almost tar-free and therefore require very little cleaning. By converting virtually all of the carbon in the waste into syngas, char residues are minimized, while syngas production is maximized. The sandwich gasifier therefore solves problems with tar, char, and clinkers in the best way possible. It avoids creating them. The syngas that is produced is clean from the start and requires very little scrubbing to make it suitable for powering an engine or being processed into liquid fuels. When not producing power or fuels, syngas is flared off. In the video footage running now, it can be seen that syngas burns with a pure blue flame that provides an indication of just how clean it is. The 1000 C heat of that flare is proof of its high energy content. The products of syngas from gasification include electricity and heat like other waste-to-energy processes, but also provide hydrogen, liquid fuels such as methanol, gasoline, diesel, jet fuel, and a wide range of additional valuable products that the client can select from to meet their market needs. This wide range of options provides the companies and communities that use sandwich gasifiers to select among the best value products for their markets. Therefore, in addition to being paid to accept the feedstocks that are used to create products, those that apply the sandwich gasifier to process their wastes or the wastes of their customers are able to enjoy far greater benefits than can be realized by burial in a landfill or by burning it in an incinerator. The sandwich gasifier is a breakthrough technology that has already repeatedly proven itself in long-term performance tests at an internationally recognized research center. It provides the long-awaited environmentally and economically sustainable solution to the world's waste management problems. The 3 R's of reduce, reuse, and recycle are the essential first steps of good stewardship. The sandwich gasifier adds recover, remediate, resilience, and reward to the sustainability tool chest. The 7 R's approach enhances the global solutions to energy and economic issues which have had a growing adverse impact on public and environmental health in the last several decades. Pollution of the land, air, and sea are global problems. This new waste-to-energy technology will conserve natural resources while eliminating wastes that could otherwise clutter the landscape and harm human and environmental health. Dakota Green Power looks forward to working with companies and communities that want to become part of the solution.